Hello student, myself Dr. Richa Srivastava, and in this video lecture I am going to discuss the topic non-sinusoidal oscillators. Now first of all, what are non-sinusoidal oscillators? We have already discussed the sinusoidal oscillators such as RC phase shift oscillator, Wien bridge oscillator. These oscillators, they generate the sinusoidal waveform at their output, but the non-sinusoidal oscillators, they generate non-sinusoidal waveform at their output. Now these oscillators, they generally use a special class of circuits known as multi-vibrator to generate the non-sinusoidal waveforms. And there are basically three types of multi-vibrator. One is bistable, then monostable and astable multi-vibrator. Now bistable multi-vibrator, they have a two stable state and the circuit remain either in a stable state indefinitely and moves to other stable state only when the appropriate triggering pulse is applied to the circuit. So bistable multi-vibrator will be used to generate the non-sinusoidal waveform, that we will see how it is the part of a non-sinusoidal oscillators. Now the bistability or the bistable circuits, they can be obtained by connecting a DC amplifier in a positive feedback configuration. Here this is a operational amplifier and it is connected with the positive feedback. Positive feedback, here this is the output, and from this the output, a part of the output, it is being fed and it is applied to the input, which is the positive terminal, and it will be added with the input. So it is a positive feedback configuration and this is the amplifier. So these two combination, they can give the bistability in the circuit. Now how we will analyze that this circuit, it is going to produce the bistable operation, that we will see. In this circuit, it is having the positive feedback with resistance R1 and R2. We cannot see any input signal applied to this circuit, and since there is no input signal, let us say we assume that some electrical noise is present in the circuit, and that noise, let us say the positive noise signal, here V plus is present. That noise signal, it causes positive increment in the voltage V plus, means the noise whichever is present, it will increase this voltage V plus in the positive direction. And since this V plus voltage will increase, then the feedback part, the voltage feedback part, it will also increase. Now this regenerative process, it will continue until the operational amplifier saturates and we get this L plus signal. Let us say the saturated voltage is L plus, we will get this saturation voltage at the output of the operational amplifier. So in this way, even if there is no signal, because of the noise which is present, noise voltage will be amplified, it will grow in the regenerative form and it will give the output voltage L plus, or we can say it as plus V sat or plus V sat voltage also. This is a bistable circuit and the input, it is being applied at the negative terminal of the op amp. Now we have to analyze the circuit, how it is going to give the bistable operation, that we will see. With this circuit, first of all we start with the simple equation for the gain of operational amplifier. The voltage V naught, it will be the A times V plus minus Vi, means the gain of the output voltage, it will be the gain of the operational amplifier multiplied by the difference of input signal. So we will see that how we are going to analyze the circuit. So now if we are not having any feedback over here, then what will happen? This V plus voltage, it will be 0. So V naught will be A times minus Vi. This is the case if there is no feedback. Okay. Now let us say in this diagram we are having this feedback with resistance R1 and this R2. So with feedback, what will happen? This VO, it will be A times V plus minus Vi. Now this V plus, in this case it will not be 0 because we are having this feedback part. So we will see what is the value of this V plus. Now there is one important interpretation from this equation. We can see, we can write this equation also in this form: A times minus Vi plus V plus. And from this equation we can see that this feedback part or feedback signal, it is being added to the input signal. It means the feedback, it is positive feedback. Positive feedback because it is increasing the magnitude of the input signal V plus. It is being added with the input signal. So, it is a kind of positive feedback. Now, from the feedback path, if we want to calculate this V plus voltage, what will be the value of this V plus voltage? It will be, we will apply the voltage divider rule, or we can apply the KCL also over here. So, by voltage divider rule, the V plus voltage, it will be V naught multiplied by R1 divided by R1 plus R2. This will be the value of V plus. Now, there are two cases for the operational amplifier. First, the output voltage, it is at plus V saturation, or we called as L plus, and second case, the output voltage, it is at minus V saturation, and we can call this as L minus. So, in this equation, this can be rewritten as V naught. For both the cases, if we write this equation, the V plus, it will be plus V sat R1 upon R1 plus R2, or it can be, second case, it can be V plus is equal to minus V sat divided by R1 plus R2. Now, there can be two cases for the operational amplifier, either the output is at plus V sat or it is at minus V sat. So, the corresponding value of V plus will also change. If the output is at plus V sat, the value will be this, and if the output is at minus V sat, it will be this. So, accordingly, the value of V plus will change if the output is at plus V sat or it is at minus V sat. The corresponding V plus, it will depend upon the value of the output. Now, if we put the value of this upper threshold and lower threshold in the equation of the output voltage, we will get two cases. First is when VO is A times V upper threshold minus Vi, and second case is when VO is A times V lower threshold minus Vi. Now, these are the two equations that will be used to analyze the characteristics of the bistable circuit. Now, coming to the transfer characteristics of the bistable circuit, this is the x axis, this is the input, this is the y axis, it is the output, this is L plus, it means the positive saturation. This is L plus means positive saturation, and this is L minus means the negative saturation voltage of the op amp. Now, to analyze the characteristics of the bistable circuit, here this is the V upper threshold and this is the lower threshold. So, we will compare this input voltage with the upper threshold and lower threshold, and we will get the characteristics. Here we can see also, if the input voltage it is less than, if the input voltage it is less than lower threshold, the output will be plus V sat, and if the input voltage it is greater than V upper threshold, it will be minus V sat. Similarly, if the input voltage it is less than the lower threshold, it will be plus V sat, and if the input is greater than lower threshold, the output will be minus V sat. So, in this way we can get the characteristics of the bistable circuit. And here we can see that this part where, and this part between the upper threshold and lower threshold, it is known as hysteresis. Now, the bistable circuit, it will behave as memory element also. We can see in this graph, in this range between the lower threshold and the upper threshold, the output it will remain constant, and the output can either be L plus or L minus depending on the state that the circuit is already in. Means for this input range, the output it is being determined by the previous value of the trigger signal. The trigger signal that caused the circuit to be in current state. So, it will depend upon the previous value of the triggering signal. Thus, the circuit it behaves as a memory element in this range. So, bistable multivibrator, it is the basic memory element for any digital system also. So, till now we have discussed the bistable circuit with inverting transfer characteristics. Now, we will discuss the bistable circuit with inverting transfer characteristics. Now, here in this diagram we can see this is the non-inverting amplifier. Why I am saying this is non-inverting amplifier? The input it is applied at the positive terminal, so it is a non-inverting, and this R1 and R2 they provide the positive feedback to the circuit. This is the amplifier with gain A. This is the positive terminal voltage V plus and the negative is at ground terminal. So, first of all we will find out the positive voltage V plus. What will be its value? Means the voltage at positive terminal of this amplifier. By applying KCL at this node, we get Vi minus V plus divided by R1 and it is equal to V plus minus V naught divided by R2. This equation it can be rewritten as Vi by R1 plus Vo by R2 is equal to V plus we will take as common, it will be 1 upon R1 plus 1 upon R2, and it can be further written as Vi upon R1 plus V naught upon R2 is equal to, we will take the LCM, so it will be R1 plus R2 divided by R1 into R2. Now, if we simplify this equation, we will get V plus is equal to Vi into R2 divided by R1 plus R2 and plus Vo R1 divided by R1 plus R2. The same equation it can be derived by using superposition theorem. Means superposition theorem, we will calculate the voltage V plus, because of first we will take V naught voltage and then we will take Vi voltage, and we will find out the final effect of these voltage at this node, and we will get the value of V plus. Now, we have to analyze the characteristic of a non-inverting bistable circuit, how it will generate the bistable configuration, that we will see. Now, once we have calculated the voltage at this node V plus, we will see the characteristics. Vo is given by A times V plus minus 0. Why V plus minus 0? Because this is the voltage V plus and this voltage is at ground potential. So, here when this is V plus and this is 0, we will see the condition when this amplifier will saturate. Whenever this V plus is greater than 0, the amplifier it will go into saturation and Vo it will be plus V sat, or we can say this as L plus also. This is the saturation voltage, and whenever the V plus voltage is less than 0, the output it will reach to minus V sat, or it can be said as L minus also. Now, we have calculated this voltage V plus. So, seeing the amplifier characteristics, it is given by Vo is equal to AV times or A times V plus minus 0. V plus minus 0 because this voltage is at ground potential. So, what is the condition when this amplifier will go into saturation? When V plus is greater than 0, the output will be at plus V sat or saturation voltage, or it can be said to be L plus, and whenever this V plus is less than 0, the V output it will be at minus V sat, or it can be as L minus. we will put the value of V plus and find out the characteristics of non-inverting circuit. So, putting the value of a V plus in these equation, we will get first, if we will put the value of V plus greater than 0, then Vi R2 upon R1 plus R2 and plus V naught R1 upon R1 plus R2, it should be greater than 0. So, from this we will get Vi, it should be R2 upon R1 plus R2 greater than minus of V naught R1 upon R1 plus R2. So, these two terms they will be cancelled out. So, Vi, it should be greater than minus R1 upon R2 multiplied by Vo, or it can be written as Vi greater than minus R1 by R2 and Vo is plus Vsat. So, it will be like this. So, Vi, it should be greater than V lower threshold voltage. This voltage is the lower threshold voltage. So, this is Vi. So, Vi, it should be greater than lower threshold voltage, then we will get the output as plus Vsat. Similarly, we can derive the second condition also. Whenever we get what is the condition when we get the output as minus Vsat. For that, we have to put the value of V plus in this equation, then we will get the condition. Now, to derive another condition for upper threshold, again we have Vo is equal to A times V plus minus 0, and first condition it was whenever this V plus it is greater than 0, the output is plus Vsat, or it can be written as L plus also. And second condition, when V plus is less than 0, the output is minus Vsat, and it can be written as L minus. To get the condition for upper threshold, we will put this V plus in this equation. So, we will get Vi R2 upon R1 plus R2 plus Vo R1 upon R1 plus R2, it should be less than 0. From here we get the condition Vi is less than minus Vo R1 by R2, and here it will be, or it can be written as Vi is less than V naught is minus Vsat. So, it will be Vsat R1 divided by R2, or it can be written as Vi is less than, this is V upper threshold. So, the condition is whenever Vi is less than V upper threshold, the output voltage it will be minus Vsat, and whenever the Vi voltage it is greater than upper threshold, the output it will be plus Vsat. Minus Vsat it is L minus, and plus Vsat it is L plus. Similarly, we can write down another condition also. When input voltage it is greater than lower threshold, output will be plus Vsat, and when Vi is less than lower threshold, output will be minus Vsat, that is L minus. Now, we will understand the graph of this non-inverting bistable circuit. The condition is when V input is less than upper threshold voltage. This is upper threshold and this is the lower threshold voltage. Whenever the input is less than upper threshold voltage, the output is minus Vsat, and as it goes greater than this upper threshold voltage, the output will be L plus. Similarly, the reverse is when input is greater than lower threshold voltage, the output is plus V. Input is greater than lower threshold voltage, the output is plus Vsat, and when input is less than lower threshold voltage, the output is minus Vsat. And this is the hysteresis part, where the output, the circuit, it will behave as the memory element. So in this video lecture we have studied about the bistable circuits, their configuration, how they will generate the output, what is the criteria and what conditions will be involved. All those things we have discussed in this video lecture. Thank you.